don't wanna go where it's coming on colored lines, where the runaways are running the night. Impossible come true, it's taking over you. We light it up, we won't come down, and the sun can't stop us now. Watching it come true, it's taking over you.
Greatest show, Knox County students. I am your host or your teacher, Miss Cox. I teach 7th grade social studies at Southfield Middle School, which I enjoy a great deal and miss you all so much. I wanted to say that today I'm going to be teaching you all about the scientific revolution. What's that? You've already heard about the scientific revolution? Of course you have. You have great teachers in Knox County. So today's going to serve as a review. So first thing I want you to do, take out your task sheet in your packet. So on your task sheet, you're going to see that we have 3 standards we're going to be covering. While I pull up the PowerPoint to go over our learning goals today, look at the standards and see if you can't identify some words that maybe you remember but you're not real sure about. Okay, I will be right back. So today, we're going to be looking at your objectives that go along with the key words that you probably underlined. I'm sure many of you underlined the terms heliocentrism and geocentrism. Today, our goal is that you will be able to define both of those words by the end of the lesson. You will also be able to explain the significance of Nicholas Copernicus, Galileo Galilei, Johannes Kepler, Sir Francis Bacon, and Sir Isaac Newton. And no, that's not the cookie. You will also be able to explain the significance of scientific tools and theories on the expansion of science. Now, I'm sure it's going through your head, why do I need to know this? Why is this important? How does the scientific revolution affect me? Well, I'm sure beside you somewhere, you have a cell phone. Did you know you wouldn't have it had it not been for the scientific revolution? How many of you have ever looked through a telescope or a microscope? Those wouldn't be around had it not been for the scientific revolution. Did you know that we could still think that the Earth was the center of the universe? And we wouldn't have the medicines and medical equipment we have today. So I want you to take about 30 seconds outside of the things I've just said. Jot down some ways that your life would be different than it is today. Now, I know that wasn't quite 30 seconds, but you can always pause the video and continue to write those down. I want you to also go out and share this information with your family and friends later on today to show them what you are already learning. Now, as we go in today, you're going to be hearing about the different scientists and their theories. In order to go through that, instead of going through it as a PowerPoint, we're going to watch a video clip that talks about all the scientists and their impact on the world through the scientific revolution. Okay, once the video's over, I'll be right back with you, and we will be doing the foldable shortly after that. All right, enjoy the video. In the mid-1500s, the scientific revolution occurred. It changed how people thought about the universe. Before the Renaissance, Europeans believed Earth was the center of everything. Polish scholar Nicholas Copernicus suggested that the solar system was heliocentric or centered around the sun. The work of Danish astronomer Tycho Brahe supported Copernicus's theory. The German astronomer and mathematician Johannes Kepler used Brahe's data to calculate the orbits of the planets. His work also supported Copernicus's theory. Many scientists built on the foundations laid by Copernicus and Kepler. In Italy, Galileo built a telescope and observed Jupiter's 4 moons move slowly around that planet. They moved in a way Copernicus said that Earth moves around the Sun. Galileo's discoveries caused an uproar. Other scholars attacked him because his observations contradicted ancient views about the world. The Catholic Church condemned him. His ideas challenged the Christian teachings that the heavens were fixed positions to earth and perfect. Despite the Church's objections, a new approach to science emerged. It was based on observation and experimentation. To explain their data, scientists used reasoning to propose logical hypotheses or possible explanation. This process became known as the scientific method. Two giants of this new approach were Englishman Francis Bacon and Frenchman René Descartes. They used different scientific methods to understand how truth is determined. Bacon stressed experimentation and observation. Descartes emphasized reasoning. Dramatic changes occurred in many branches of science at this time. English chemist Robert Boyle explained that matter is composed of particles that behave in knowable ways. Isaac Newton used mathematics to show that a force keeps the planets in orbits around the sun. He called this force gravity. He also developed a branch of mathematics called calculus. Thank you for watching. Hope you enjoyed the video. Let's talk about some of the things that you learned. So, going back to our objective, we talked about heliocentrism and geocentrism. In the video, you saw that heliocentrism was when the sun was in the center of the universe, and geocentrism was when the earth was in the center of the universe. You also found out about key scientists. Nicholas Copernicus developed this theory of heliocentrism, which challenged the original teachings of the church. Galileo developed the spyglass, which would later result in the Kepler telescope. So his inventions and scientific tools helped lead to the scientific revolution. Other things that some of his inventions played a role in, or other scientific tools that were developed, are things like the microscope, and they would come out of the scientific revolution as well. Johannes Kepler, you learned that he focused on how the earth and how the sun and how the planets orbit, okay, which means go around. Prior to him, they believed that it was a perfect circle like this tennis ball, that it went in a perfect circle all the way around. However, Kepler was saying, no, it's more of an egg. It goes in that oval elliptical. So those are some different things that we learned about Kepler. So he helped us determine how planets move in the universe. Sir Francis Bacon helped develop the scientific method, which was a way for us to understand how things work and how we can observe and make experiments. And then Sir Isaac Newton led to the law of gravity and the 3 laws of motion, which we're going to see during our foldable. Speaking of our foldable, we are going to be doing that as soon as we go over this final objective. That we can explain the significance of scientific tools and theories on the expansion of science. Well, we've already talked about some of those theories, the elliptical theory, the theory of gravity, the theory of the laws of motion. Those tools were the telescope and the microscope, and they were significant in helping people better understand the world around them. Now, for your foldable, you will need to get the paper from your task in your packet that says foldable or flipbook, And you are going to bring it. You're going to need some scissors. And you're going to need a pen or a pencil and some markers or color pencils. Take a second to gather that information or those resources, and then we'll be back to see how the foldable works. I'll see you then. Congratulations, you have made it to the final section of the video. And in this section, we're going to be working on our foldable. Now, each of you had a piece of paper that looks just like this in your packet. And what's going to happen is we're going to turn this piece of paper into a foldable. I know it doesn't look like a foldable now, but it will be. I want everyone to put your finger on this box right here. This box gives us the directions of using the text provided to answer the essential questions on the inside of the foldable. Then we're going to sketch a picture or create a symbol that signifies the bold word or words, such as Galileo, Kepler, Copernicus, the three laws of motion, elliptical orbits, and so on. So the first thing I have to do is I need to flip this piece of paper over, because that section you put your fingers on is actually the back of your foldable. Now, if you'll notice through the paper, you can still see these lines. You're going to fold inward on those lines to where it almost creates like a shutter going into the inside. Now, if it's not exactly right, that's okay. Like, see, mine went a little crooked. That's okay. And then I'm going to fold in the other side, doing the same thing. Once I've done that, I'm going to go back and I'm going to cut along each line to make the flaps movable. Once I've done that, you might give each one of them just a teeny tiny tug to pull it the rest of the way over. Don't pull it too hard or you'll pull them off. Okay, so then I look in my first section and I see there's a question. List Newton's 3 laws of motion. And you're like, well, we talked about that in the video a little bit, and we talked a little bit with some of the different slides in the PowerPoint, but I don't quite remember that. That's okay, because we have provided a reading for you. And in your reading, they are in order. So you have like Newton's laws of motion, elliptical orbits, geocentric model of the universe. So they all go in order. So, first thing I'm going to look at is this section right here, Newton's 3 laws of motion. Okay, so when I write Newton's 3 laws of motion, I'm going to list them out. And I've already done this for you on a separate foldable. So, on the inside flap, this one right here, I'm going to write those 3 laws that I see right up here. Okay? An object at motion tends to stay at motion unless acted on by another force. Now, that's not the entire law, but I have abbreviated it. And I know that I need to look back in my notes to see the rest of the law of motion. Okay, and you can do that because the space is limited. Alright, 2, force equals mass times acceleration, or F equals ma. And then the last one is for every action there is an equal and opposite reaction. So all I had to do here was to list out the laws. Okay, on other questions you might have to explain or describe, but on this one you just had to list. Then in this next section, you're going to draw a symbol or a picture to represent one of the laws. Well, I chose number 1. An object tends to stay at motion unless acted upon by another force. So I drew my neighbor riding his unicycle because he's been doing that recently. And so as he's riding his unicycle, he's having a good time. And then all of a sudden, Mr. Tree is in the way. What happens if he continues the way he is? Well, he's going to hit the tree. What's going to happen when he hits the tree? He's going to be stopped. Because, according to this law, an object, being my neighbor on his unicycle, tends to stay in motion unless acted upon by another force, which would be the tree. So when he hits the tree, he will be forced to stop. So I draw a symbol for each of these. And so you can always look back at this section of the video to see exactly how we drew the symbols and how we answered the questions. And you're going to do this for each and every one of these. So I have enjoyed working with you all today, and you all have worked very hard. And I am just super excited to see how your foldables, or if you want to call them a flipbook, turns out. You can have your parents, or you can do it yourself, and tweet Knox County Schools and share some of your masterpieces with all of your teachers, because I know they are always looking and seeing all the great things that you're doing. And I speak for all your teachers when I say that we miss you and we look forward to seeing you again. I hope you all have a great rest of your day and a great rest of the time that you have with family or whoever you live with. And you all have a great day. All right. Goodbye.